Good morning, learners. My name is Alhassan Kabore. I'm a software engineering student at Ghana Communication Technology University. Today, we are going to talk about caching techniques. And we are talking about caching techniques. We are dealing with memory management. How we can able to manage our memory, whether we are using phone, we are using laptop, or any device. If there is a memory, how can we able to manage our memory? And we have types of memory. We have RAM, we have virtual memory, we have cache memory, we have a lot of memory. But today our focus is going to be cache memory. And cache memory, before, what is cache? When you say cache memory, what does it mean? So moving on to our next slides, we are going to look at the definition of cache memory. When you say cache memory, a cache memory is a small and a high speed memory located closer or inside the CPU. And you know your CPU. CPU is the central processing unit. Its main job is to store frequent use data and instructions. So the CPU doesn't have to fetch them from slower main memory. So that is how the cache memory does. High speed memory, store frequent access data and instruction to reduce access time. So that's the cache memory, definition of cache memory. Looking, why is it that the cache memory is very important? Why is it that the cache memory is very important? Cache drastically reduces memory access time and speed up processing. It does this by taking advantage of two key principles. We have temporal locality and we have spatial locality. So as for the temporal locality, it access recent access data is likely to be accessed again. And for the spatial locality, data near the recent access one is likely to needed next. So that's how the difference between the temporal locality and spatial locality does. And when it comes to cache memory, so cache memory has its own levels. There are 3 levels of cache memory in modern CPU. We have first level, we have second level, and we have third level. As for the first level, it is closer to the CPU code. It's split into, we have level 1I for instruction and level 1D for data. It is very fast and its approximation is about 1 nanoseconds. It's very small. All these things is the features of the first level. It's very small. It's around 30 to 120 KB. That's a kilobyte. So it is dedicated per core. So we see, as for the size of the first level is around 32 to 120 kilobytes. So that's how the first level of cache memory does. So let's move on to the second level. The second level here also, it is very large but slightly slower. Its size is around 256 kilobytes to 1 megabyte. Access time. Its access time is approximately 3 to 10 nanoseconds. So level 3, the level 3 of the cache memory, that one too is also larger but slower. Its size is about 2 to 30 megabytes or more. As for the second and the third level, it shares among multiple cores, CPU cores. It shares among multiple CPU cores. Its access time for the third level, its access time is approximately 10 to 20 nanoseconds. So we could see it clearly that the first level is very fast. As for the first level, it's very, very, very fast. The first level is very, very, very fast. And looking at the technology behind cache, cache is made from static random access memory. Cache is made from static random access memory, which is faster and more expensive than DRAM. And we know DRAM is what? Dynamic random access memory used in main memory. So as for the DRAM, you use it in the main memory, but as for the SLAM, is very fast. The static one is very, very fast and it's expensive. That's why cache size are small. So because we are is made from static random access memory, that's why the cache size are small, but they makes a big difference in performance. Its performance is very, very high, but the size of the cache is very small. So let's move on to the summary of today, the cache. Let's move on to the cache, the summary. I want to summarize everything so that in our next meeting we are going to look at the visual memory, and look at some of the visual flow of the cache memory, how it works. So let us summarize. So in our presentation for today, or our tutorials for today, what I want you to understand or to know is that the cache memory speed up CPU performance. The cache memory speed up CPU performance, and it stores frequent access data. And it has 3 levels. We have the first level, which is very, very, very fast. The second and the third level share among. So even with the first level is very fast, but the second and the third level, they share their data in common, and they are very, very large as compared to the first level. But you could see that the first level is very fast, but the size is not big. It's too small as compared to the second and the third. And also, one thing I want you to know that it uses locality of reference to predict what data the CPU will need next. So we see we have I don't want to talk about it. In our next meeting, we are going to talk about it. We have the reference and references. You know, when you go to your CPU, we have memory address and we have the value of data or the data. So the data is stored in the memory address, whereby we will command the CPU to look for a data in the memory address. So in our next meeting, we are going to talk a lot about memory, whereby we are going to focus on the visual memory. But today, our focus is that we are able to know the definition of memory cache, know the levels of memory cache and what it does and their features. Able to understand that there are 3 levels. The first level is very fast, the second level is large, and the third level is also large, but they share data in common. Also, it uses locality of reference to predict what data the CPU will need. Thank you for joining me. In our next meeting, we are going to talk more about our memory. Thank you.